is Gautam Balakrishna. I'm a data science trainer. I specialize in Tableau and as well as R programming. Those are my key skill sets. So let's just begin. Basically, in this section of the course, there are some discussions on the data analytics, and there are various topics that are covered here. What is data analytics, and how do you interpret information? What is the purpose of data analytics? What are the various key components? What are the various applications and industry related information? What are the types of analytics? When you look into the data, how do you understand the various attributes, or you can use the word variables in the data? How to clean data, so things like that. So I will try to use practical examples and explain this rather than just running through the slides. So here it talks about thinking about analysis early. How do you start with a plan? How do you code? How do you clean the data? How do you analyze, and how do you interpret the data? So once you have done this, then basically how do you reflect on what you have analyzed? What did you learn? What are the conclusions that you have been able to draw? So basically these are all you can call a life cycle of analysis, starting from as soon as you get the information. Your manager or whomever you're working with has probably shared with you a set of data, whether it's in Excel form, or whether it could be in the form of a ERP system, or in a database form. You might be writing some queries on the database. Let's say it could be Oracle database, MySQL database, or SQL Server database. So they might have, your management might have given you access to this database, and you're looking at hundreds of tables, and then you are trying to see what kind of information is available in the systems. But before you actually do that, you would have got a goal that you need to look at the sales data and analyze why sales is impacted. Is it they could say that we have a few competitors, so here is the data about competitors. Here is a list of products that they sell. Here is a list of the pricing of the products that they actually sell in the market. And then you have to look at your data, your product information, and your sales information, and probably compare. Okay, these are the average prices of these products that my competitors are selling in the market. So what's wrong with my set of products? Aren't my prices competitive enough? So you draw some correlation between the prices of the products, and also you look at what is your marketing team doing? How are they advertising? Are they using some digital marketing? Are they using store-to-store, door-to-door marketing campaigns? Are the campaigns effective? So basically, you study the data, you look at the information that is in front of you. You have to talk to people. You'll probably be talking to marketing people who are in the various departments, or you might be talking to the sales force people who are on the ground running, trying to convert customers. So look at what challenges they have. So basically, there are a lot of interviews you'll be doing with various people in the business, and try to understand what's actually going on, and why your competitors are doing better in the market compared to what you're doing. It applies to every field, whether it is just retail, sales, marketing, or it could also apply to HR. So if your company is not able to convert projects, let's say if you have service requirements to fulfill resource requirements for customers. So if you are not able to fulfill, and some of your competitors are able to fulfill these resource requirements for managers or any positions, then you start reflecting on what you are not doing right and what they are doing right. So that's kind of the first thing that you see in terms of analysis. So let's say if they have exposure to services of, let's say, monster.com or job portals, or various search engines which can help them get resources. So you will try to see what kind of search engines that you use for looking for resources, manpower, and then you'll see how you can improve your services, how you can reach these people faster, and convert your orders. So that's basically an overview of how you should analyze and interpret information. So why do I need an analysis plan? So basically the 3 points that I mentioned here to make sure that
Arvind here. Let's see, the thing is, so when you're talking about the data analysis part, so is it assumed that there'll be a team, because I'm looking at a position of, let's say, I'm the CEO of a company. So would I be having a team that will be absorbing this data from the various sources in the market? Is that what?
So can you give me a scenario Can you give me a scenario? So according to that scenario, I can talk about it.
For example, let's say I had a real estate firm, and I'm the CEO of the company, and I'm reporting to the owner. Now, in that position, I basically, my role is to see what data I've got and then interpret the data and give the solution to my management. So,
so for you, management is for you basically your customer. Basically a purchaser of real estate property, right?
Correct.
He could be a domestic customer, or he could be a corporate customer, correct?
He's a domestic I'm talking about. So basically he's buying a house. So the first part.
So analytics is, yes, exactly. So basically analytics is helping your customer is one thing. But if you're, let's say, the CEO or the managing director of your company, the first aspect of data analytics that you will be looking at is how do you help your business grow, right?
Correct.
That is, there are 2 aspects, and then the second thing would be that how can you help your customer in the sense identify, let's say, the right kind of property. Let's say you are associated with 5 builders, let's say in Bangalore location. So if you are associated with 5 builders in, let's say, north part of Bangalore, south part of Bangalore, east, west, and central. So let's say these are the regions. So this is how your real estate market is divided. So depending on that particular customer's requirement, you will basically already have the data. So either through your you have to get the get the things moving. You have to let's say have a system in place. It could be a simple system. It could be a simple MySQL database where you collect all the information and store it there. It could be Access database or Excel. If the data size volume is not huge, you could probably put all this information in Excel in various sheets and then analyze this information. And also use R or any software to analyze it. So because what happens is, just to give you an example of Excel. So let's say this is data that is stored in the form of Excel here. And I have 3 tabs of information: list of orders, order breakdown, and sales target. So here I have some information like what is the order number, what is the date of the order. I have the customer. Let's imagine, for example, if I have got this data through a certain agency or through a certain online service provider, and let's say this is data about some competitors in the market and what are the items that they are selling. So if I don't have the header information, you can see how difficult it can be for me to understand this data. So I have this date information. So I have to assume, okay, this must be something to do with the number. That is a sequence of numbers. So looks like auto-generated or some kind of sequence of numbers. This has some information about dates. And looking at this, it looks like probably names of customers. And this could be the city or wherever that person is located. And this has some information about demographics. So what country and what region. So this talks about what kind of consumer. So home office or corporate customer, things like that. So there are additional information. So basically the this information is known as the metadata. When you say metadata is about data about data is what you call as metadata. So it basically helps you understand what this information stands for. So this is order date, this is order ID, this is shipping method. So it clearly tells me these products are shipped from a certain location. So you can analyze, you can understand by looking at the data what kind of information it is. And here we have the list of orders, we have the order breakdown. So when I say order breakdown, it's probably the individual items that are connected with each of the orders. So for a specific order number, we can see here there are 2 items associated with that order. And it also has some information about sales price or profit associated, how many quantities were sold, what is the category of the items that were sold. So here I can see, if I put a filter on here, I can see the various categories. So furniture, office supplies, and technology. So but just by looking at this information, I know that, okay, this company deals with majorly these 3 kinds of items. If I have to look at products, I can see, okay, there are various products that are sold, and there are subcategories for the products. I can see there are accessories, appliances, binders, bookcases, chairs, paper. So various kinds of items are sold. And there are some sales targets associated. I think this is for the sales people to guide them what kind of targets they have. It's probably a monthly targets associated with each category of products that the sales team is trying to sell. So by looking at the data, this is basically what I'm able to analyze, and I can do some interpretations. So what my data is all about. So once I collect my data, then I make a problem statement like, why am I analyzing this information? Because there is a problem. There are thousands of formats of collecting information. So let's say, for example, I am looking at this is a software called Tableau that you'll be looking at in your later sessions. So if you look at it, don't just think in terms of big data. Just if you look at the from a data perspective, just from a data perspective itself, on a basic level, you would be probably on a day-to-day basis working with Excel or text files, Access. There are some JSON files, statistical files, and also you could be, these are some of the basic files that you'll be looking at. Also, you might be connecting to, let's say, some Microsoft database, like a SQL Server database. You could be connecting to Oracle database. You might, if you are, let's say, a service provider for Amazon, let's say, for example, and you sell some products through the Amazon portal, right? You could be using some of the Amazon products to connect to and analyze how your products are being sold. Let's say you have a website. Okay, in most websites, if you are aware, they use MySQL as a database because it's really light and it's very compatible and goes very well when you're using when you're having your own websites. Let's say you want to collect data about how many people are visiting your website and what aspects. Let's say if this is a website, you want to understand the click stream. Basically, you want to understand which areas of the website they have clicked on. So basically, to understand what kind of products they have shown interest in, right? So all that information from the website might have gone stored into the MySQL database, and then you access that data, and then you analyze. Okay, in certain geographies, certain regions, customers at certain times have clicked on certain products on your portal, and try to by clicking on that, it means that they have shown interest. So you can understand based on their interest how you can vary your prices. So let's say they are clicking on it, they are not purchasing it, or 50% of the people who are clicking on it are not purchasing it, or 70% of the people who are clicking on a certain product are not purchasing it. So the price might be of certain interest, or they might have looking at the price, they might have sent out an inquiry or asking for discounts or things like that. So based on that, you make decisions on how you can efficiently sell your products, right? Tableau or R, you can connect to a lot of systems. And then if I click on more here, you can see I have an iota of systems. Hundreds and hundreds of databases and systems I can connect to. I can connect to ERP systems. You can see here various products. You can also connect to your big data. When you say big data, something like a Hadoop environment, right? So
Right.
Cloudera is one of the data stacks, is one of the environments. So
Okay.
I can connect to Google Analytics. For example, if I am using some as part of my website, let's say if I have a website, and as part of my analytics, I have tied up with Google Analytics. So I have bought some Google services, or simply if I'm using SEO, for example, search engine optimization. So search engine optimization, if somebody is searching on Google and does my website appear in the first 2 or 3 pages of search, right? So if it's if my website or any products that I sell through my website, or the real estate products or something, if it is not if it's not showing up in the first 2 pages of Google search, that means something is wrong. So I want to analyze how my search engine can be optimized further. So big data, Google provides its big data query solutions, and also there are a lot of other products, IBM, SAP. Let's say you're working for a multinational, and they are using a lot of SAP products, right? So let's say ERP systems. Let's just look at the Excel data that we just looked at. The name of that Excel is Amazing Marty U. I'll connect to that Excel here. So as soon as I click on open, I can see that the 3 sheets inside my Excel, the list of orders, order breakdown, and sales target, have appeared here on the left-hand side, right?
Okay.
So the same Excel, list of orders, order breakdown, and sales order, these are the 3 sheets within my Excel. Right. They have appeared here on the left-hand side of my screen. And now this is basically called, different people use different names, but what I have commonly seen is the right term used is a canvas. So you can call this section where it says drag sheets here as a canvas. So let's say I can drag my list of orders into the canvas here, and as soon as I drag it, you can see here Tableau brings all that information from the Excel into the grid section here, right? And I can look at the data, and I can also look at the metadata. And let's say I want to change the names. I can also go ahead and change the names, and I can change some information that suits my convenience, And then let's say if I want to join some data, because I know here that my list of orders is connected to the order breakdown, correct?
Right.
Because the order ID is basically like a identifier for the information. For each order, I have order date and customer associated. And in my order breakdown, for each order, I can have multiple product information associated with that, correct?
Right.
And then I know that based on the order ID, these 2 are connected, my list of orders and order breakdown. Right. And then I can do the same thing here. I can then go and drag my order breakdown as well. Right. And as soon as I drag that, I can see all that information from the order breakdown with the price, profit, has automatically been joined with my list of orders. And you can see here, this is basically a symbol of a join. And in this join, I can see there are 4 kinds of join, which we will be going through in detail in future classes. It's basically joined it based on the order ID. Right. That's all we need to understand as part of this class. Once I do that, you can see here a pop-up kind of thing has appeared, which says go to worksheet. If I click on this worksheet, I can see all my data has been classified on the left-hand side into 2 major sections. One is called the dimensions and the measures. Okay, the dimensions are basically qualitative information, qualitative or categorical information. And I say qualitative, it represents the quality of the data. In the sense, my customer name represents a category or a quality of information, and my measures represent quantity. In the sense, profit, quantity, discount. So this is all quantitative information, sales, right? These are all numbers. So numbers can be represented, or numerical data can be represented and they can be called as quantitative information, and whereas dimensions and all this information can be called as qualitative information, because this represents a kind of quality. Region represents, a geographical area, and country, state, city, this represents the geographical information. So it has a certain quality to it. Whereas the measures don't have a quality to it, but they basically talk about quantity and what is the price, what is the how much was sold, but it does not tell me what was sold. It tells you how much was sold and at what price something was sold. But if you want to know what was sold, that is basically a quality. So you know the certain product was sold in a certain category and on a certain date in a certain region at a certain price. Basically you have to look at the measure. So that's how all this information has automatically been categorized by Tableau. Now so going back to this, right? So it says, why do I need to analyze? To make sure the questions and your data collection instruments will get the information you want. To align your desired report with the results of analysis and interpretation. To improve reliability, consistent measures over time. So basically these are some of the aspects. I would also like to show you this pyramid. So basically this is kind of a standard that is followed in the industry whenever it comes to data analysis or business analysis. So if you can see here, at the highest level, when you are analyzing your data, the first thing is, if you can see here at the top of the pyramid, that's a statement. So this statement says that in 2 months, analyze archived clickstream data to determine the website changes that will most efficiently increase revenue by 15% on a month-to-month basis compared to the same month last year, right? So what this statement is either provided if you are the owner of the business, if you are the entrepreneur, or if you are the managing director of the company, this is probably the statement that you will be making and passing it on to your team of analysts so they can work on it. Or if you are the analyst, your management or your VP or your director, whomever you're working under, or the stakeholder of the company that you report to, that is a kind of statement. He will give you a set of data. He will say, okay, I have this information regarding my website stored on a MySQL database on a server, and here is the link to the server, and go ahead and analyze this data. But at the end of 2 months, this is what I want you to analyze for me. I want you to analyze all the website data and all the click stream and help me increase my revenue by 15%, right? So help me identify how I can increase my revenue by 15% on a month-on-month basis. He could be making this statement because there could be a lot of competitors in the market and he's fighting these competitors in the market. So he wants your help in understanding how I can use the information generated from my website to increase the sales, right? Increase my revenue. So increasing revenue could be, to increase revenue, you might need to sell more, or you might also analyze that you might have to bring down the product, you might have to bring down the price of the products, looking at the price of the competitor products. So, or you might have to offer some kind of, let's say, Christmas offer or a New Year's offer or a Black Friday sale. You have to think about some campaigns that you have to introduce in the market. So let's say that the current campaigns are not bringing you the desired result. So let's say your company is spending, let's say, $100,000 every month on campaigning, or let's say 10 lakh rupees if I have to talk in terms of rupees. So, and you analyze that the campaigns are not being very effective. So then you can talk to your management and say, the campaigns are not very effective. They are not giving us what we want. So the digital marketing is not helping. So let's say you want some marketing guys to go out there, go to malls. Let's say, for example, go visit malls on the weekends and then give out pamphlets to people, or take products along with them and then give demonstrations of products, or set up a tent there and then demo these products. So you have to then analyze, okay, how you can achieve these goals that have been set by your management. So once you have set the goal, or let's say once the manager has set the goal for you, the next step is to break that into achievable results. So now the next layer, how you would break it is, you would then look at the data the way we were looking at the data, and then analyze what kind of aspects of data, what kind of attributes of data that you need to look at, right? So this is my second step. So I will look at total dollars spent per transaction. So for managing the website, there is a certain amount of money that's being spent. So you would analyze what is the total dollars spent per transaction. Let's say a customer has visited the website and clicked on a product and purchased that product. So you will then analyze what is the total spent field aggregated by sum over each transaction. So then you will then also look at what is the total dollars spent per month, what is the total dollars spent per customer. So you will analyze various sets of information within the data that's provided to you, and then as you progress, you would then break it into further smaller steps. So here you can form certain smaller questions like, do specific demographics disappropriately contribute to revenue? So what are the contributions of age, gender, and income? So let's say, for example, if you have income information about the customer, if you have other demographic information like gender or age, so you can then categorize the sales data into these categories and see, okay, let's say you sell certain products on your website that are related to electronic goods, or let's say they could be some digital products like iPods or cell phones, Android phones or iPhones. Then you can categorize, looking at the demographic data, you can look at categorizing what are the sales, what are the what age category, let's say from the age category of 16 to 21 age group, how many iPhones or iPods are purchased by this age group compared to, let's say, the age group of 22 to 27. Or you can look at gender wise age groups. So you can look at males in a certain age group, what kind of products they are interested in compared to males in a certain age group. So you can do a lot of correlation and also analysis based on income groups as well. So this is how you need to break the problem statement or break that goal into smaller pieces, and then attach various attributes to them and then analyze the information. So that is one way of achieving your results. Now moving on to the next sheet. So key components of a data analysis plan. So what is the purpose of the evaluation? So we already discussed what is the purpose. So there are some goals, there are some needs in the business which require, everything is most likely it would be driven around competitors, or it would be driven around increasing your revenue, or also there could be certain challenges or problems with respect to sales. Different industries can have different aspects. So we are talking mostly from a sales marketing point of view, but let's say if you think about a healthcare industry or a pharmaceutical industry, so they could be looking at how basically drugs react. So they might have sample data or clinical data that talks about application of certain drugs on, let's say, mouse, right, on rats. So basically they might have collected information on how these mice or rats behave on administration of certain drugs, and the response of these creatures to the drugs might be captured in a database. And basically based on this information, you need to analyze how effective these drugs are over a large set of data, test data that is performed on these animals. So basically you can use that data to interpret the effect of the drugs. So similarly, you can think about some other industry. For example, let's say industry specific to that deals with gemstones. So let's say, for example, the clarity of the gems, how they define the price of the gemstones or the diamonds that they are selling. So the clearer the gems, does it really matter if the gems are very clean or well cut, and how are the prices of these gemstones defined? So you can use your data to understand, and you can use various methods of analyzing the data. Now, I just mentioned about quantitative data. So quantitative data is presented in a numerical format. It is collected in a standardized manner. It is analyzed using statistical techniques. So if you go back to Tableau, so the measures are the quantitative data, and that is what I have been talking about here. It is presented in a numerical format, collected in a standardized manner. And quantitative data we gather in extension are more generalizable than qualitative data. Stating limitations weakens the evaluation. So survey data. So let's say, for example, you want to understand the market in a more efficient way. So let's say, taking the example of a real estate scenario. So you want to understand how you want to, let's say, price your real estate products. There could be apartments, or there could be houses, condos. So basically, you will go in.
I'm sorry to interrupt. Unfortunately, I don't know. With this real estate example was because of my question, or generally you want to give a real estate example? Because
no, I want to be more practical with what you guys are like. So let's say, for example, you simple example, right? Let's say you are a reseller of certain products, and you have a website through which you sell products, and you also sell products through your various stores that are located in various malls. So let's say these products are healthcare products, let's say used by athletes or people who are into bodybuilding, or it could be, let's say vitamin supplements, right? So you have these supplement stores, right? You see in malls where you can go and purchase all these vitamin supplements, or bodybuilding supplements, or it could be supplements for athletes and things like that. So you want to analyze, so in certain regions in your locality or wherever you live, what could be a good location, or what could be whether it would be a right investment to open a store in a mall. So before you can open that store in that mall, you want to do a quick survey. So to do a survey, let's say you hire a company that conducts surveys. So what this company would do is they would go set up a tent or some kind of a makeshift location in a mall, right? And they put out pamphlets out there, and they might have some posters of bodybuilders or athletes, your favorite football athletes and cricket or any other sporting athletes. They'll put up these posters, and then they will say, okay, these athletes consume these products for fitness and bodybuilding or whatever, right? And then they try to market these products. And basically, when somebody approaches them, you might have seen they note down your cell phone number, or then they collect some information like your date of birth, or basically what is your interest, what do? You go to college, you work, what kind of work do you do? If you earn, what is your basic salary, or do you work on a hourly basis? What kind of information? So they try to collect some information. So you would have seen also whenever you're in malls, these people selling cigarette packs, right? They are out there, they are selling some new brands of cigarette or new products, and then they collect some information from you. So they're collecting all this information for survey purpose, and once they gather all this information, then they basically analyze this information. They get an understanding of what kind of people live in that area, what is their how much are they earning, would that be a right investment to open a store in that area, would people be interested in buying the products, and things like that. So that is basically information on survey. Here, this diagram basically talks about using past business performance information to predict the future. It also talks about quantitative analysis and evidence-based analysis. So just to put this into some kind of real-time example, let's say, for example, I want to simply compare my profit. I'll just drag in my profit here and my sales, and then I don't want to aggregate this, and so sales, instead of sales I will just take the order date, and instead of the year I will just take month and year. And here I can see that there is, this is basically time series data. Instead of sales, let's use profit. That would be more. Okay. So here I can see that I have information related to my monthly profit over a period of time. Let's say for the year I have information from 2011 to 2015, and I can see that this information where on a monthly basis I can see that the pattern in which my profit has changed over a period of time, right? So I don't see a specific trend, but let's say, for example, I want to use some analytical tools here. So I want to see the trend of how my profit has changed over a period of time. And here I can see that my profit margins have been, this trend line says that my profit margin has been kind of constant. So if I was just looking at the data in the Excel form, this might not have been, this kind of quick analysis might not have been very easy, because if I had to look at all the profit information over a period of time and then being able to analyze that in Excel or any tool, it's not that easy. I mean, you can do it, of course, if you're a very good analyst with Excel, you can quickly do that. But you can see with Tableau, with using visualization techniques, it can be so quick and so easy to analyze this information. So you can see here the trend, it clearly says that your profits have not been increasing, but it's not been declining also very much. So this is what my trend is saying. Now let's say based on this data, now I'm worried. So I want to analyze my profits for the coming years based on the existing trends. So I can also use some forecasting methods, and then I can forecast all this information for the future. So here I see that the forecast is not active, but I can use some forecasting techniques, and I can forecast based on current trends how my future sales could be over a period of time, right? So that is what I wanted to discuss as part of this particular slide here. Here it talks about business analytics and business intelligence. So here it talks about past and future and exploratory data. So in terms of business analytics, it talks about the typical techniques and data types: optimization, predictive modeling, forecasting. So that is where business analytics is. Business intelligence is basically your data warehouse systems or business intelligence systems. They basically help you build some dashboards, or they are basically just give you information about what kind of information is there in your database or in your Excel or in your systems. Whereas business analytics talks more about how you can use that data and do some forecasting or statistical analysis, or run various statistical techniques and predict the future. So that is what this sheet is all about. So what are the applications? So you are talking about, you don't want to talk about your current industry you have been working in. So basically here is just a small set of applications. email marketing. We talked about email marketing. So email marketing is basically where you're sending out emailing pamphlets to your customer, to a list of people that you have in your database. Let's say through some agency, you have collected a lot of information about people in that region that you want to serve, and you want to email out some pamphlets to them or advertise some stuff to them. So you can then decide, looking at their interests or survey data, which kind of customers you want to send out this information. So promotional activities, which is the same as the above. Healthcare, we discussed some examples of healthcare. Insurance. So insurance companies can use the information to decide, let's say for example, it's a vehicle insurance, right? Automobile insurance. So automobile insurance companies can decide how they want to price their products based on the geographical data. So let's say based on the number of accidents that occur in a certain region in the country, they can decide how they want to price their insurance products, right? So if they are in a region, let's say, if you take the example of US, so let's say northeast part of US, like cities like New York or Boston, you see that you end up paying very high insurance premiums compared to somewhere, let's say in the central part of US, where or in the smaller towns or smaller localities, where insurance prices are much lower, because there is a higher risk that insurance companies face because of the number of uninsured people or number of accidents that happen on average. So insurance companies look at all this information before they can price their products. So customer relationship management. So when you collect information about customers, you can then serve them better, right? It's very simple. Financial and marketing activities, we already discussed about it. Supply chain management. So let's say your movement of goods in, let's say you are into business like FedEx or courier services, various kinds of courier services like DHL or that move goods from one place to another, and you look at supply chain analytics. So how can you improve your movement of goods, right? How can you make sure that your goods reach your customer at the earliest? So you might be looking at weather patterns, you might be looking at traffic situations, right? For example, Google provides traffic information. So at various locations, in various cities, at various times. So how can you avoid traffic at certain peak hours, or air traffic? Air traffic control provides air traffic data. So you can look at when you can fly your goods at what times, and then you can improve your supply chain. And also you can improve the pricing. So human resource management. So we discussed several examples. Pricing decisions. So you can make pricing decisions based on competitor data, or based on survey data, or based on your marketing sales information. You can make decisions based on pricing. Sports team game strategies. All major sporting teams in the world use it, whether it is baseball or NBA or cricket or football, soccer. All teams and coaches have huge teams that they use the game strategies. So if it is American football, then probably you look at how you want to place your quarterback, how you want to place your running back, what would be the right team combination to go against a certain team. So basically, if you are into cricket, then you will look at basically based on the pitch conditions, whether it is a fast pitch or whether it is a slow turner, what kind of pitch conditions, what kind of teams you want to make, and basically based on the opposition players. Okay, if they have a lot of fast bowlers, then what kind of batsmen you want to have in your team, things like that. So you can make these decisions. So in future courses, we'll be looking at some examples also around this. So how does business analytics helps in? It helps in profitability of business, which is clearly understood based on the examples. It helps in the revenue of the business, of course, shareholder return. Okay, whatever money, time they have invested on the business. So shareholders are always looking for return on investment. It also enhances understanding of the data. So it also helps businesses to remain competitive compared to the competitors. So it also helps in creation of reports. So we just saw some reports that we were able to create based on the data that we have. So that was some of the information. Now, descriptive analytics. There are three major types: descriptive analytics, predictive analytics, and prescriptive analytics. We already discussed about the prescriptive analytics. So let's say, basically looking at some campaign data, it can prescribe, okay, your products are not that good. You need to spend some more money on R&D, or you need to spend some more money on your campaigns, things like that. So those are prescriptive analytics. Predictive analytics we just saw. So basically, based on existing data, you can then predict, how your sales could be in the coming years, things like that. So other than that, you also have descriptive analytics. So let me just show you an example of descriptive analytics. So let me create a new report here. So all I'm going to do is I'm just going to drag my country here, and I'm going to drag my sales into something called as the size, and then I am going to put profit into color. So as soon as I do this, you can see here in descriptive analytics, what I could not analyze in my Excel was basically just by looking at the data. I want to understand what are the various regions that that records sale of products, and I also want to record what is the profitability and sales with respect to these regions. If I have to do this in Excel, I have to spend some time. I have to do some VLOOKUPs and join this data, and then also basically view and draw some graphs here and analyze the data. But you can see here, using some analytical tools or data visualization tools, as soon as within a few drags, I can see here how my sales are. Let's say, for example, if I click on country, and then also it goes into various regions, and I can see here I have some orange dots here. Do you guys see that? So here on the legend, I can see on the left hand side of the legend, all the profits that are below zero, that is basically the loss making regions. So basically I can see here Netherlands is recording a loss of $37,000 or whatever the currency is, and I can see here that France and Germany are doing very good in terms of profitability. And also in terms of sales, I can see here the bigger these dots, it also means that higher sales. Smaller dots means that the very low sales. So basically, this is what I would term as descriptive analytics, because I'm able to describe, I'm able to make it visually understandable compared to, let's say, my data in Excel. I am able to clearly describe my analytics here, right guys? So we were able to understand what descriptive analytics is. So using data to understand past and present. So I have been able to use the data to understand the past and the present. I have been able to understand how my products are being sold, and how much of my products have been able to have I sold, and at what price, and what is the profit. So this is basically an example of descriptive analytics. We already discussed about the others. So based on this, I can make decisions, right? Retail stores usually run clearance sales by reducing the prices to finish their inventory. So we know whenever we go to malls or stores, we see these sales. So whenever we are walking through the aisles, we see there are always sales on certain particular items because they want to clear those items before they expire. So how do they make these decisions? So they make these decisions by looking at the inventory. They look at on a daily basis, on an hourly basis, how many of these items get sold. If they feel that there is a chance that these items cannot be sold in the next 1 month or the next 15 days, then they have to push these items out before they can before these items expire. So they can apply to the vegetable section, the dairy product section, because they have to make sure these items are sold within a stipulated time. So then you'll use your descriptive analytics to examine historical data for similar products, and you will analyze their prices, how many units were sold, what was the advertising done. So basically, if I can compare that to this example, I can see that Netherlands is not doing very good, and they are recording a lot of losses. So what will I do if I am the sales head for all the regions? So I would call up my sales manager in Netherlands and ask him what's going on. What is going on with the business, and why are you guys not having such low sales or profitability is affecting. So then you can have a discussion and you can come to some understanding on what are the problems that he could be facing in his region. So let's say if he says that there are a lot of competitors and we have to look at having competitive pricing for our products, or let's say there is a very high capital expenditure, maybe they are spending a lot of money on the shop floor, or the locations where they are paying a lot of rent, maybe on a monthly basis. So there could be a lot of factors, and then looking at this information, you can then decide, how you can basically help your sales guy to improve the sales in the various regions. So that was one example. So predictive analytics, you can predict sales based on prices by analyzing historical sales data. We already looked at that example. And prescriptive analytics, so find the best set of pricing and advertising to maximize sales revenue. So those were some of the aspects. So data for business analytics, we already looked at it. We have to look at collecting facts and figures. So whether it is through campaigns, or whether it is through surveys, or if you're working for a big organization, for a multinational company, they might be providing their website data, or they might be providing ERPs, databases, or might already be in place. So you might be getting exposed to these database systems. They might be giving you access to these database systems, so you can understand data. Continuous variables, like I showed you in Tableau, and there are two types, numeric variables, and these are nothing but your quantitative data, continuous variables, and categorical variables. So these are your categorical variables. For example, the product name, product category, subcategory, country, region, segment. These would come as categorical variables. And then continuous variables, age in years, weight, blood pressure reading, temperature. So if I can compare with that, your quantity, profit, discount, these would come under the continuous variables. And categorical variables, just now I talked to you about them. So under categorical variables, there are two types. So ordinal and nominal. And also there is a binary type. So ordinal variables are categorical variables with some intrinsic order or numerical value. So for example, if you can look at education. So basically there is a certain order to it. No high school degree, some college degree. So you can see that there is an order to this. So if I have to order this data, my first order would be no high school degree, then a high school degree, then there is some college, and then there is some college degree. So there is a sequence that we see here. So agreement, so strongly disagree, neutral, agree, strongly agree. So you can see that there is a certain sequence that I can see here. Rating, excellent, good, fair. So these are some ordinal variables which follow a certain sequence of or an order to them. So nominal variables would be like a nationality: American, Mexican, French, Indian. There is no certain order to it. Nobody comes first here. You can alphabetically order it, of course, but from a business perspective, there is no such order to nationality. Anybody could be ordered first. For example, race or ethnicity, favorite pet, right? It's not necessary that a cat comes first and a dog comes second. Any creature, any animal can be placed first in the list. It may be alphabetically ordered, of course, but other than that, there is no such ordering for these particular categorical attributes. So that was some examples. So these are some examples of categorical. Now the binary kind of ones are simple. They would be in terms of yes or no. The answer, you would generally answer with a yes or no. So did you attend the church picnic on May 24th? Did you eat potato salad at the picnic? So the answer would be either a yes or a no, or I don't know, I don't remember. So, but in any case, it would answer in most likely scenario, you would have two answers, yes, no, or the third answer could be I really don't remember it if I actually had potato salad at the picnic. So you could leave the answer as null. So that these are some of the types of data. So process of translating information gathered from questionnaires or other sources into something that can be analyzed. So sometimes coding is required, basically because sometimes the information that you have, they might not be categorized in a certain order. So you might have to categorize that information. Say, for example, if I analyze my region data, and once I analyze it, I realize that there are three regions: central, north, and south. And let's say, for example, you as part of this business are only interested in the north and the south regions, and you really are not interested in the central region. So basically, now you have analyzed it. Now you have to code it in certain way and see how you can filter out the unwanted or the information that you don't want to show. So let's say, for example, you can then transform it, or you can create a calculation, or you can create a group. So let's say you just want to see the north and the south group, and you don't want to see the other information. So you can remove that information from the screen. Or you can also create a calculated field, and instead of using that region, you can use that particular only two regions. Or you can use a filter condition, and then you can say that I only want to use north and south, and I don't want to analyze any other information. So that is what is meant by coding. So there are some common coding systems. Zero, you can, if data is present in yes or no, you can then convert it into numerical 1 or 0 or 1. So these are some of the coding examples. So dummy variable is a variable that is coded to have two levels: yes, no, male, female. Sometimes here there's an example of cigarettes smoked per week. So if you have survey, and based on the survey, you are capturing, like let's say a tobacco company like Marlboro or Camel is collecting some information. So how many cigarettes do you smoke per week? So if the person answers around 3 packs or 4 packs, or I just smoke 1 pack, or I just smoke 1 cigarette a day, or I really don't smoke. So you have collected all this information. Now you, from the analysis purpose, all you're interested in is whether that person smokes or he does not smoke. So all you want to capture is a yes or a no. So you can look at the survey data and collect all the information, and wherever the person says I really don't smoke, or I have quit smoking, You can put all that, you can categorize all that into 0, non-smoker. And if a person says, I smoke occasionally, or I smoke often, or I smoke a pack a day or a week, then you can categorize them, all that data, into a category of 1. Because from your analysis perspective, let's say if you're not interested in knowing how many packs he smokes in a week, all you're interested in knowing is whether he smokes or not, then you can then convert that. You can convert that categorical variable into a dummy variable. You can create a dummy variable, and you can assign, you can program that data to assign 1 or 0 to know whether a person smokes or not. So similar to that, there are several other examples. You guys can look at these examples to understand how you can assign various codes to the data. We will be looking at, of course, we will be looking at a lot of examples in the future sessions. This is just a walkthrough of creating dummy variables and how you can assign values to these variables. So you can create age categories and then also use the age categories in your analysis. Let's say if you don't have any categorical data in your age, it's just a number, but for your analysis purpose, you want to put people into certain age groups, and so you can target your marketing on certain age groups. So by having age groups, you can target your audience. For example, just to give you an example, 10 to 19 year age group. So if you, let's say if you're selling game CDs, right? So gaming CDs, or it could be your Microsoft Xbox, or PSP, or any products. So if your target audience is in the 10 to 19-year-old age groups, you will direct your campaign activities to, let's say, certain places in geography where you know that this age group is most likely to visit. Let's say if you are selling game CDs for the 10 to 19-year-old age group, you will probably be looking at play schools or certain areas in community, like play areas in parks, right? For example, that is one, play areas in parks where kids really visit to play. Or you might be having some campaigns in amusement parks. Let's say you go to an amusement park, and outside the amusement park you have these guys who are selling CDs or marketing their products for kids. So that's how you can target your audience by doing that, by categorizing your age groups. So one approach is to group together responses with similar themes. For example, I didn't feel sick enough to see a doctor. My symptoms stopped. Illness didn't last very long. So these could all be grouped together to illness was not severe, right? So that's another way of doing it. So that is coding. So once you have coded, you will be looking at cleaning your data, because the way I showed you the data in this Excel sheet, it is not necessary that all your data that you receive or you'll be looking at will be in such clean format. Sometimes, product names could be missing. Sometimes, these dollar values that you see here, some of them you might see a dollar, some of them it might be in a different currency. For example, if you're a global organization and if you've got your sales data from different regions, then if you're focused on Americas and Europe and Middle East and Southeast Asia, so in India you might be getting the same information in terms of rupees, and in Europe you might be based on the different countries in Europe. UK, since it is not part of European Union now, so you might be seeing pounds. Other parts of Europe you might be seeing euro. So you have to convert all that currency into one standard format. So let's say if dollar is the standard that you want to use, so then you will use your currency conversion for that day, for that hour, and use the currency conversion methods to convert everything into a dollar. So you have to do some calculations for that. So those are some of the challenges that you will see in real life scenarios. So there could be some missing data, like I told. So if there is missing data, you might have to look at some other sources to fill up for the missing data. So you can set some limits. You can also set some, these are called as governance rules. So basically you need to govern your data. You need to set some rules. So people who are using this data, they can follow those standards. So you want to set some age limits for size limits for the numerical data for age. So let's say you don't want to have more than 3 digits captured for age, just so you make sure that there are certain standards followed in terms of data. So the data entry systems should not allow double entry. For example, Mark was talking about, he was working in cost accounting. So ensuring that double entry of, let's say, a voucher or any kind of invoice or anything should not be allowed. So if double entry is allowed, then you'll have duplicate data sitting in your system. So your systems have to make sure that they take care of all these rules with respect to the quality of the data, maintaining a very good quality of data. So univariate data analysis. So what is univariate data analysis? So it serves as a good method to check the quality of the data. Inconsistencies or unexpected results should be investigated using the original data as the reference point. Frequencies can tell if many study participants share a characteristic of interest, age, gender, etc. So examining continuous variables can give you important information. Do all subjects have data, or are values missing? So are there outliers? Basically you can look at data and you can understand if there are outliers in data. So let's say, for example, if I connect to a different file, so basically, I just wanted to talk about outliers with an example. But anyway, those will be discussed in the future scenario. So here there is an example of some data for various age groups. So for example, here you can see that this data is mostly in the age group between 10 and around 40 years of age group. So all the data that is lying here is lying in this range. So it could be survey data or it could be anything related to surveys. So all that data is lying in this age group. Whereas here you can see that this data is distributed around or it is dispersed. You can use, I don't know if dispersed would be the right word. So this data I can see here is I have a set of data, and this data is for many different age groups. So I have data for someone who, for people who are in the 80 plus age group. I have some data that is scattered around the 60 plus. Some of the data is around the 50 plus. But you can see, I can see a certain pattern here. Most of the data is between the age of 0 and 60, and some data is lying around 60 and 80. So an outlier in this scenario, I can call this data that is in the age group of 80 plus as an outlier, because the analysis that I get when I analyze the data that is, let's say, in the same range, it could give me a different result if I am analyzing something based on age. There is some set of data that is lying outside the scope of my data, that is beyond a certain age group. and there is no continuous continuity in the data. There is a break in the data, and there is certain set of data that is lying outside of the standard set of data. So this would be called as an outlier, because this information is lying outside of the standard set of data that is in the standard data set. So that is what my definition of a outlier is. So in when you're doing your analysis, you will be using various functions like mean, median, mode, range of values, because you need to understand to understand your set of data. You need to understand, because if it is a small set of data, it's easier to understand. But if you have a very large set of data, you will not be able to go through. You will not be able to go through all the data and analyze it. Here in this scenario, we have, let's say, for example, tens of thousands of records. It's hard to go through each and every set of data. Let's say if you want to analyze, certain characteristics about the people, or let's say if there is an age of the customer, or if you want to analyze how many quantities of certain items were purchased over a period of time. You cannot manually analyze it, and if you want to understand the patterns of the data, you need to be able to use some statistical calculations to arrive at it. So mean, for example, it tells you what is the average of all the values. So if I have 1,000 values of age, so I want to understand what is the mean age group. So it helps if I am able to understand the mean age, it tells me, okay, out of my customers, the mean of the customers, let's say, are in the age group of 30. So I know what my data looks like. What is a median? So what is a median compared to a mean? So median is kind of the middle of the data compared to a mean. Mean is you add up, let's say, if I have 1, 4, 7, 3, 2, 1, if these are my values. So if I have to take the mean of it, what I would do is I will add 4 plus 1, 5, 5, 7, 12, 12, 3, 15, 15, 2, 17, 71, 18, and then divide it by the number of occurrences, 1, 2, 3, 4, 5, 6. So 18 divided by 6 is 3, right? So that would be my mean. Now, how do I calculate the median? So median would be, first thing I have to do is I have to sort my data. So if I have to sort my data, then first would be 1, and then next would be 1, because I have another 1, then I have 2, then I have 3, then I have 4, and then I have 7. So to take the median, I have to see, okay, I have 1, 1, 2, 3, 4, 7. So what are the middle numbers? The middle numbers are 2 and 3. So my median would be somewhere in between. So it would be a 2.5. That would be my median. So what would be the mode of operation? Mode is what is the number that occurs the most number of, repeats the most number of times. So 1 is the number that repeats the most number of times. So that is the mode. So what is the range of values? Range of values are between 1 and 7. That would be my range of values. So that is some of the basic statistical analysis of the data. We also looked at the, what would be the here in terms of percentile, for example. So here it tells me the mode, and here it tells the median, and this is basically a maximum. In our case, the maximum is number 7. So narrow distribution, we already went through it. So standard deviation is a method that you use to understand how distributed your data is. So out of the current example, if I have, let's say, I have 1, 2, 7. Now, if I have a big number, let's say 27. So this is basically an outlier, because this is not fitting into the standard range of or the sequence of data that we have. So in this case, we will have a bigger standard deviation, because from the center value, this number 27 is deviating a lot. Whereas here, standard 7.6 for the first scenario, if there was no 27, if you take this data set, from the middle value, my data is not deviating very much. So in this scenario, if 3 is my mean, the number 7, the number 4, the number 1, the number 2, they are all very close to my median, whereas the number 27 is very far away from my median. So basically, I have a bigger standard deviation. That means my data is distributed not very evenly, like in this second scenario. So we can also look at distribution with respect to percentile. So let's say, for example, we have this data of age with frequency. Let's say it's something to do with kids in the age between 0 and 11. Basically how much, how frequently they lose their teeth, for example. So when a kid is a newborn in this age of 0 to in this age of 2 to 3 years, it starts losing its milk teeth, and then it loses some more tooth. So basically, if you have a sample data with 1,000 different points, and if you plot this on this graph of age and frequency, this graph tells me that there is a very normal distribution. So at the peak age of 6 and at the peak age of 6 is when kids lose the most amount of their milk teeth, and the new teeth are basically formed. So if I can take this example, so I can see that this is basically like a normal distribution, where I can see most of the kids lose most of their teeth or tooth in this age, in this age group, and as the age increases, they stop losing teeth. They start losing teeth, and then they stop losing teeth. Somebody's chatting. All right, Mark. Have a good one. Bye bye. So can we continue on this session for a few more minutes, guys? I think you have to. You guys have offers.
Yeah, I'm fine. I'm fine, Satam.
Okay. So who else is on the call? So Deepak is on the call, and I see that Somyaju has just left the call. So hi Deepak, I didn't get to know from you, but anyway, hear from you. Anyway, so basically this is how data is distributed. So similarly, there is a different example where we see that there is something called as a left skew distribution, left skew distribution is where basically there is more of the data that is distributed towards the right hand side, and the left hand side there is not much distribution. So basically this was some example of distribution and percentile. Now distribution of categorical variables should be examined before more in-depth analysis. So here we have some examples of number of people in various regions, Midwest, Northeast, Northwest. So basically this is example of some survey data on where people reside. So using the bar graph, the categorical data has been shown here. So this is a basic way of analyzing your data. You just show it in a tabular form, and then you analyze the data. So here we have categorical variables, and in terms of percentage of people who have attended high school, people who have completed their high school, people who have attended some college, and out of that there are some people who have got a college degree. So basically, if you have to show in terms of percentage, so this is how you can do it. The same data can be represented in terms of different categories also, as shown below. We'll be looking at a lot of these examples. This is just theory, so I'm just walking through these examples. So basically, you are using categorical variables to observe the percentage of people in that category. For example, you're using categorical variables to observe how many people have less than high school or have not attended high school, right? So this data shows me that I'm using the categorical variables to understand what is the percentage of people who have attended school, right? And your understanding before correcting the survey was that most of the people who attend college have a college degree. But after the survey, you realize that there is a lot of people who attend college, but most of them actually more than 35, almost 35% of them don't finish their college or don't get a college degree. So at the beginning of the survey, you were expecting that there will be a very high percentage of people who have attended college, but they have not completed college. But you understand that based on the data, that it is basically not that much, or you can understand that most of the people have not even attended college. They have dropped out after high school. So this is what we analyzed here. And so again, this is coming back to the same problem, identifying and solving business use cases. I showed you the example of the pyramid. So this is exactly that pyramid. So you identify the problem, you set a goal. If you are the at the highest level in the food chain, then you set the goal. Otherwise, your manager will set the goal for you. And then you break the problems into small, workable and definable problems, and then identify the possible solutions with respect to the various attributes or variables that you have. Right? So this is the pyramid that has been discussed here. So recognize the problem, define the problem. Defining the problem is very important, like we already discussed. Structure the problem, analyze the problem, interpreting the results and making a decision, implementing the solution. So once the interpretation is done, let's say you understood that, your marketing campaigns are not good, your R&D is not good for the product. So then you implement the solution, right? So basically you improve, you work on investing more money on R&D. So that would be your implementation, correct? You hire better engineers to design your products, etc. So that is the implementation part of the solution. So that is outside, I would say, outside of the scope to a certain extent from what we are doing. So again, theory stuff, problems exist when there is a gap between what is happening and what we think should be happening. So just now we saw in this example, right? So we were thinking that most of the people get into college, get a college education. But we understood that once the survey is done, that there is a big gap in our understanding. Most of the people, don't go beyond high school education. So here we see that more than 30, here there is 30%, here there is a big drop from high school to college. Whereas we expected that most of the very few people actually drop out after high school. So there is a big difference in our understanding. So defining the problem is not an easy task, so that we have understood. So if there are several competing objectives, so the problems could be humongous set of problems could be existing. So in terms of in terms of not being able to sell products efficiently, the store managers might not be very efficient at selling products. The campaigning might not be working that well. The products, quality of the products, there might be a lot of complaints regarding the quality of the products. So there could be a lot of competing objectives also. So you want to increase the sales, but more than the sales, you also want to increase the profitability. So that could be a lot of competing objectives. So external groups, like for example, competitors are, let's say, for example, they are bringing their products from a different country after making it at a very low cost. So for example, if a product is designed in India, it would cost more to manufacture that product than, let's say, some other Southeast Asian or Asian country, where the competitor is actually bringing that product from a different country and marketing that product here. So that could be external groups are impacted in defining the price of a product. So there could be similar other time constraints. Basically, you don't have a lot of time. Your year end is approaching and you need to show some results. So we already went through the pyramid, state goals and objectives, characterize the possible decisions, identify and constraint, clearly break down the goals into further stories. So analyze the problem. Managers interpret the results from the analysis phase. So incorporate subjective judgments as needed, understand limitations. You guys can go through the slides whenever you have time. And then implement the solution. Translate the results of the model back to the real world. So based on the results, work on the making it work in the real world. So Coca-Cola is a good example. I also was not aware of this. So we all thought that the Coke formula to make Coca-Cola, that is the defining thing about Coca-Cola. But here they say that what they have that is really best is their algorithms, that they have some algorithms that decide the texture, taste of their orange flavor products based on the orange juice. So basically what they're saying is the oranges or the orange juice that they get from the market, they might be having different tastes, they might be having different quality, so they might be getting it from different locations, and then they might be coming up with their orange flavors. But what they are saying is that to achieve the same consistent orange taste for their orange flavor juices, let's say it could be a Fanta or it could be any other Coke product. So every time we drink it, we get the same consistent taste. But the oranges that they might be getting from, let's say some of the oranges they are getting, it could be from within the US itself, if they're manufacturing it in US. So let's say they are coming from Florida, or if there is shortage of supply, or because of some weather related issues, they might be getting it from South America or India or some other country. Now Indian oranges, as we know, they will be tasting much different than oranges from Florida or South America. So but they can't, their product has to taste the same. So what can they do? So they have to make sure that there are certain mixtures that go into this orange juice that gives the same, make sure that it gives the same texture and taste. For this, they have some proprietary algorithms. So these algorithms are basically embedded in their machines or their systems they use, and they make sure that the concentration, the taste, the quality, everything matches the defined flavor. So irrespective of whether the flavors are different based on the products, based on the oranges they receive from different places. So it's a very complex algorithm they probably use, and this is one amazing aspect of using the data analytics and data science in the real world. So that's how I wanted to summarize this session. So there are a few open questions. So companies producing millions of Minute Maid, how can they test the bottles? Are they testing a small set of bottles? So Minute Maid is, again, you might have, it is just like Tropicana. We have Tropicana in India. You would have seen those Minute Maid, smaller Minute Maid, packs. So there are some open questions here. You can think about these questions, and then we can discuss in the next session. Take care.